Now, it is very logical to see why wind, and especially the trade winds, brought boats from Europe to the West Indies. Now, they use sails. They had sails on their boats that catch the winds, just like the wind that blows a flag around. Now, it's also easy to see why people ride canoes downriver, riding the current. Now, it's not easy to see how a steam engine or an internal combustion engine can run a vehicle, but it's easy to see how a river that is moving, let's say, a mile a minute, a mile an hour, can bring you from the highlands to the sea. How did people make the jump to the steam engine? They needed heat, right? They needed heat for their houses. They didn't have ovens. They had a village oven. Everyone had to take their bread to the village oven to bake it. So the steam engine came about. So now, what do we have that is not very obvious? Hydrogen on demand, right? Copper chloride in water at 550 degrees Celsius at X atmosphere, decomposing the water into hydrogen and oxygen. That's a concept. Now, it turns out that the melting point of the copper chloride is almost 500 degrees Celsius. So they went to 550 degrees Celsius to ensure that the copper chloride is part of the water in solution. Now, when copper chloride combines the chlorine and the water, the HCl forms, right? Now, salts are ionic, I think. They naturally break down in solution to ions, in this case, copper ions and chloride ions. Now, the chloride ion and the hydrogen ion makes up hydrochloric acid. We studied that in chemistry before 1980. Now, we learned about acids and bases, about salts, but they never said sugar. But it's salts and sugar, right? If it's not a salt, it's a sugar. I guess. Sugars are inorganic chemistry. Salts are organic chemistry. It's funny. Maybe I'm mistaken. Which one is organic and which one is inorganic chemistry? Where the carbon compounds are concerned, it has to deal with life. That's a different branch of chemistry, but I don't remember the name for it. But now, Crystals form and they sometimes have water trapped in them, called water crystallization. Now, the water is trapped in the crystal. Is that water trapped as a molecule? And if there are different water molecules, which crystal favor what water molecules? How are the bonds and how strong are the bonds? When you think of it, what India did with their nuclear reactor, use a heat to have the water at 550 degrees Celsius and put a copper chloride in it and extracted hydrogen and oxygen very efficiently. Now, the energy exchange does not favor producing hydrogen and oxygen that way as a business. But the business is not producing hydrogen and oxygen. In that case, hydrogen and oxygen are a byproduct. The business there is to produce electricity using nuclear reactors. So you can realize uses for byproducts and new synergisms in places where it was not possible before. Now, take for example the Chinese quantum computers. They have both the one that goes down to minus 273 degrees Kelvin and the one at room temperature, which is a photonic one that solve their problems that other supercomputers cannot. Why? Why did they do it and then, you know, the West cannot do it? Because, when someone is teaching at a university and there's a student, that student has to wait until a position opens up to become a teacher. That's why. They are not interested in growing the economy, they're interested in keeping it the way it is. So the ones who are benefiting from it will continue to benefit from it, right?